This week we're going to be looking at energy and thinking about how carbon emissions, methane emissions, and all of the greenhouse gases are impacted by our energy choices and our energy usage. This first figure that I'm going to start with here, I want to give a caveat to before we even get into the discussion. This was produced from the BP 2018 Energy Outlook. So they are a company who has an interest in fossil fuels. However, when I look at all of the other data out there, I am finding very similar types of information. And I actually found this study rather disheartening, as I actually thought that folks in like China, India, areas in Asia were really pushing the renewable envelope, and that renewables were becoming a much bigger part of the sector. But that's really not reflected in what we're seeing in this document. So what we're seeing here is that over the next 20, 30 years, we're going to sorry about that. We're going to continue to see an increase in overall use of fossil fuel producing fuels. Oil is going to go up a little bit and then stabilize somewhat. Gas will continue to increase. Coal may continue to increase in the short term and then should start to stabilize or even taper off. We're seeing more and more uptake of nuclear in the short term and then leveling off, and hydro is pretty much leveled off, with renewables being the next piece that we are seeing an increase in, and that we really hope to see an exponential increase in as we move further into the future. And so one of the things that I want you to understand and think about is that we are not in any way, shape, or form at a point where we're going to actually limit our greenhouse gas emissions significantly over the near future. And this is a big problem, and this is why we've got everybody, out there discussing what are we going to do, how are we going to reverse the issues, and how are we going to not end up in some of those horrible future scenario types of situations where we just keep polluting, and we push the Earth's temperature way beyond anything that we've ever experienced. When we look at Canada in particular, narrowing the focus a little bit here, this is again from BP's Statistical Review of World Energy. It's a different study, different year of a study, but they have some of the best analytical partners out there to actually do these analyses. So they often have great figures that you can borrow if you're preparing sustainability presentations. There is also the Canadian Energy Research Institute, CERI, that also has great different figures that you guys can pull for your presentations as well. So when we look at Canada, what we see is that we see, luckily, very little coal in Canada, especially since Ontario divested of coal quite a while ago. Other provinces do still use it, but it's not a significant portion of our overall energy consumption. Really, gas, natural gas, and oil are big components, but thanks so much to all of the freshwater systems that we have in BC, Quebec, and Ontario, hydro continues to remain relatively high from a percentage standpoint for our energy production. In Ontario, as you probably know, we have a fair amount of nuclear. A lot of other provinces do not have the nuclear that we have. And our renewable slice is about 3%. There was actually a really interesting study that came out from Stats Canada just the other day that talked about renewables in the Canadian energy sector and how it's still very insignificant in proportion to all of the other energy pools that we use from. If we actually break down that renewable piece, what we see is that actually a lot of it was biomass for a while, but people have sort of tailored off on the new biomass buy-in. And so I haven't seen much growth in biomass lately. There has been a lot of growth in wind, especially in some areas. In Ontario, for example, probably one of the best areas to see a wind installation is Wolfe Island, down by Kingston. Huge wind installation there. Lots of wind installations also on the coast due to the nature of the wind. Solar has remained a tiny fraction of our market, and biofuels have remained a tiny slice. And remembering that back in the 1990s, biofuels and biomass were combined. They were considered sort of one pool of energy, and then more recently people have been splitting those two off to look at the differences between the two and the growth in both. And biofuels, often things like corn, switchgrass, anything that is a sugar-rich type of agricultural product. All right, so if we look at fossil fuels basically make up 85% of the world's commercial energy, and those are primarily portioned into coal, which again is still a huge deal in the United States. When I lived down there, I could not believe the amount of coal and clean coal that just is constantly on the rail yards. As well as in China, coal is actually continuing to increase. Oil is still a significant portion of our total fossil fuel usage, as is natural gas. And with natural gas, we're starting to look at different types of pockets to extract natural gas. So here we're actually looking at coal reserves, but a lot of the areas that have coal reserves also have underground shales that are really high reserves and high resources for natural gas. And so then we do what's called fracking to remove the natural gas from these same types of areas as well. But again, if we look in the States, there's still quite a bit of coal that hasn't been mined. It's still a really big business, and it's still one of the main ways that they actually produce energy. They, in response to concerns for carbon, they created clean coal. So clean coal was the idea that you're not going to have as much emissions of carbon dioxide and other types of things, because what you're going to actually do is you're going to limit the amount of sulfates, nitrates, a little bit of CO2, and things like that that are produced by having everything, all of the reactions occur in a slurry. So you're doing everything in sort of a liquid medium, and you're still having gases produced which pump the turbines and generate the energy, but you've got this liquid medium that keeps some of the nasty stuff from spreading. Now the challenge with that is that then you have this coal ash, it's called. You've got this sort of slurry of bad things, arsenic, lead, sulfates, all these different types of things. And they typically put those in train tankers, and they ship that off to some area where they can store it. So for example, Indiana is the biggest importer of clean coal waste in the entire country. So they have all of these lined pits where they just put all this waste, and it is a toxic nightmare. I'll find for you guys the image I have of when one of the coal ash dams broke down south and the damage it did. It just destroyed farmland, croplands, people's homes, everything. And it's leading to a lot of areas that are really highly polluted. And unfortunately, a lot of these areas are in areas where it would be great to do agriculture. But now they will never be able to do agriculture in these areas. So really, getting back to it, I think that there's really no such thing as clean coal. We may be able to do things differently to prevent atmospheric contamination, but that ash that we end up with at the end, or the slag as some people call it, is actually really toxic to environments. So the U.S. has the world's largest coal reserves, and they still import more coal because the reserves are not sufficient enough to meet their growing demand and need for coal. So I've grabbed here a little bit more to tell you guys about the coal ash problem. So again, this coal ash is highly toxic. It's often stored in these pond areas, and we've got this groundwater contamination as well whenever these ponds start to leak. And in 2009, the EPA actually classified coal ash as hazardous waste. So here's one of the images of a coal ash dam that broke. This obviously used to be a beautiful farm with farmland and all of this, and they had a flood, and then the flood put extra pressure on the dam that they had holding back all the coal ash, and it just flooded the area. So this person was never allowed to go back to their home. It's again completely toxic. And it's now covered a massive area in Tennessee that used to be able to be an area where you could farm and live, but you can't even live in now. So when we look at coal ash studies, the EPA actually did a study trying to understand exactly how many toxic coal ash sites there were. And there's approximately 137 problem coal ash sites that are contributing to drinking water contamination in the following states: Arizona, Connecticut, Florida, Illinois, Iowa, Kentucky, Louisiana, Michigan, Nebraska, New York, North Carolina, North Dakota, Ohio, Oklahoma, Oregon, Pennsylvania, South Dakota, Tennessee, Texas, Virginia, and Wisconsin. So when we start to talk about the coal ash problem in the United States, it is a problem. We are talking about drinking water contamination and drinking water facilities that are not equipped to remove these toxic chemicals from the drinking water. And it's having really large and lingering effects on some areas. There's actually a few documentaries that have been done looking at people who are seeing cancer clusters and other types of things from their exposure to these chemicals. So to give you an idea of this coal ash challenge that we're seeing as a result of clean coal is a major environmental consideration. So if you end up consulting in the States, this is a piece that you need to remember to roll into your water planning for the business that you're working with. All right, if we switch gears now and we talk about oil instead of coal, if we look at oil reserves, we see that obviously the biggest oil reserves, the largest oil reserves are still in the Middle East, and they are significant. They are more than 5 times the oil reserves in any other continent. So those oil reserves in the Middle East, and that's why there's so much tension around relationships there, are the biggest and most important in the entire world. So here, if we look at the top 18, what we call giant oil fields, you can see that they're in Saudi Arabia, Kuwait, Saudi Arabia, Iraq, Abu Dhabi, Saudi Arabia, Iraq, Iran, Saudi Arabia, Iran. All of them are in the Middle East area. So one of the things that you need to consider, again, when you're consulting in different areas, is understanding the geographical profile that responds to the use of energy in those areas. So while these guys in Saudi Arabia, for example, have huge amounts of oil that they have access to and that are a big revenue generator for them, the other thing that they have is they are actually putting a lot of money into renewable energy technologies because they're also of the understanding that their oil reserves will eventually run out, and they want to be industry leaders in renewable energy technologies so that they can continue to be energy suppliers to the world. If we look at Canada and the US, there's a really interesting dynamic that we see happening between imports and exports between Canada and the US with energy products. So if we look at exports to the US, we see that about 79% of Canadian production of oil goes to the US. About 51% of our natural gas production goes to the US. 41% of our uranium goes to the US for nuclear. 22% of our petroleum products go to the US for manufacturing. 11% of our electricity gets transferred to the US, and a lot of that is through the transfer of electricity from BC Hydro, but also a huge portion of that is from Quebec Hydro going to the US. And only approximately 1% of our coal production goes to the US. Now, if we look at things that we actually import from the US, we also import oil from the US. We import natural gas from the US. We import petroleum products. We also import electricity in some areas. And we also import coal. So it's a really interesting dynamic that we see. But because our countries are so massive, it sometimes makes more sense to do trading from a north to south perspective than it does from an east to west perspective. And so sometimes we see even what's happening in Newfoundland and Labrador and things like that. If things are coming in by ship, we actually see some stuff going there from the US that would make more sense than to ship something from Vancouver to Newfoundland. All right, switching gears again, let's talk a little bit about biofuels. We mentioned biofuels previously. The idea behind all biofuels is that you're growing something, so you're reducing carbon dioxide in the atmosphere as that carbon is being taken in as we grow these byproducts. We then typically produce some type of an oil from the biofuel, or when it's algae, we also do other types of reactions as well. But that oil can then be used as an input to drive vehicles, power different electricity generating stations, and things like that. In 2009, the US produced approximately 10.5 billion gallons of ethanol. So some would say ethanol is a biofuel, others would say it's not. It's definitely an additive in gasoline that allows us to leverage the burn, as it were. And most of the ethanol comes from corn as a feedstock. So what's interesting is in the US, corn is subsidized, so you actually make different sort of ratios of money in the US versus Canada for corn production, and then therefore ethanol is actually cheaper to produce in the United States than it is in Canada. But actually the second largest producer of corn and ethanol is actually Brazil. So there are areas of Brazil that are just agriculture central, and if you ever went there, you'd swear you were just standing in the middle of the prairies where they're just growing crops. It's really kind of an interesting thing. You go from really protected lands in Guyana and you go across a river, and it's like, I have just gone from the wild, jungle into Iowa. It's the most bizarre thing I've ever seen, honestly. Anyways, and Europe is also the most important biodiesel producer in the market. So in Europe, they use rapeseed for a lot of biofuels, and it's 58% of the global biodiesel that gets produced in the world comes from the European rapeseed that is produced. And although biofuels have been a resounding success in Brazil, where they displace about 50% of the gasoline consumption and don't use rainforest land, the US and European experience has been not quite as positive as what we've seen in Brazil. Again, there's different types of biofuels, and they're usually ones that tend to be sugar rich. So sugarcane, obviously, is a great biofuel, so is corn. You've got lots of carbohydrates in the corn. But people have also used poplar trees. They're fast-growing tree species that have a lot of mobile sugars in them. Switchgrass and miscanthus as well, which are also both really quick-growing grasses and a really good source of sugars. So here's a little bit of a map across the US to give you an idea about the different types of biofuels that are grown in different areas. And a lot of this just has to do with soil types, water availability, and plants' reactions to the environment. So you can actually see that in the Northeast here, a lot of it is young, fast-growing tree species that are used as biofuels. So as we look at hydropower is a pretty good form of renewable energy. There obviously is much less from a fossil fuel emission standpoint. You have less pollutants. There's no sulfur dioxide, nitric oxide, no carbon monoxide, dust, mercury, any of those types of things that you'd get from coal. It's also relatively safe for the workers, and compared to nuclear power, you don't have any of the nuclear waste issues. There's no uranium, there's no toxic waste dumps, any of that kind of stuff. So hydroelectricity is a decent renewable energy source. Now, there are obviously some challenges with building hydro dams. You have the initial outlay of cement and concrete that you need to build the dams with, and this does create fossil fuels, so it's not a completely neutral source from a fossil fuel perspective, but a lot of the dams have already been built at this point. They already exist, so we're not looking at any additive fossil fuel production from hydro dams. In Canada, hydro is a huge part of our electricity grid, and obviously in Ontario, we've often referred to our power as hydro, just because it's the main point with which we actually get our energy. And Hydro-Quebec is actually the world's largest hydroelectric generating company, and they generate something on the order of above 30,000 megawatts of hydroelectric energy. It's pretty phenomenal, and that's why a lot of their electricity gets transported to other provinces as well as to the states, and they make quite a bit of money by selling power. So hydropower can obviously be absolutely wonderful. If you look at Brazil, Canada, Norway, Switzerland, and Venezuela, they are the only countries in the world where the majority of electrical energy production comes from hydroelectric, except for countries like Paraguay, who not only produces 100% of its electricity from hydroelectric dams, but it also exports 90% of its production to Brazil and Argentina. So Paraguay is in an amazing position with regards to renewable energy and hydroelectric power. Norway also produces 98 to 99% of its electricity from hydroelectric sources. So again, where you've got fresh water, glacial melt, and lots of steep ravines, you've got lots of great opportunities to build hydroelectric dams. Now, I want to be clear, there are definitely some environmental challenges with regards to dams, and I could spend all day telling you why dams can also be bad. A lot of it has to do with limiting fish species and their ability to migrate to their regular spawning zones. We've also seen that dams can cause serious challenges when you first create them, as you create the reservoir and flood land. There's examples of lots of areas where they've lost a lot of their farmland and people have lost a lot of their homes as they've built dams. But in general, there's approximately 800,000 dams on the world's rivers at this point, and 500,000 rivers have been altered for navigational purposes because of dams. So there are some folks that are like, hey, so we're changing the actual entire watershed, the entire flow. We're changing how the rivers can flow because it does modify river flow. So you've got now where you might have had steady flow, or you may have had something that increased flow rates through rapid areas and things like that. You're now changing those dynamics, which can lead to higher levels of siltation if you have water moving slower and then faster in other regions. It can lead to, again, major challenges for fish species, and diversion or draining can also cause some major challenges as well. There's been a couple huge dam projects that have happened globally recently. There's the Aswan Dam project in Egypt, I believe, and then there was another huge project called the Three Gorges project in China, which is one of the largest engineering dam projects ever completed. All right, so as we're winding up here, if we look at renewable energy, we know that the renewable power generation capacity for hydropower, ocean and tidal powers is fairly static, and there's not a lot of growth in these areas. Solar is continuing to grow. Bioenergy has remained fairly static over the last little while, and wind energy has grown slightly, but we're just starting to see geothermal creep into the market. And I think that geothermal energy is going to be an area that, especially once the US jumps onto the renewable energy market, they're probably going to look fairly heavily at geothermal as a renewable resource. All right, so renewable possibilities. There is the chance for 100% renewable energy in approximately 139 countries, and we do see countries making transitions. What's really interesting is a lot of the countries that are sort of increasing their standards, and as they're increasing their energy needs, they're actually increasing their renewable energy portfolio due to funding from external sources. And so we're actually starting to see a bit of a push in nations where we would not typically have seen these renewables growing in the past. And these renewable technologies could lead to a 42.5% reduction in overall energy usage as well, because of the efficiency of renewable resources. So the other thing you have to remember is the way that we currently generate energy at like nuclear power plants or hydroelectric dams, and then send that energy over great distances on power lines, you lose a lot of the energy that you've produced just through the transmission process. So when you have closer point source types of renewable energy, you actually save a lot of energy overall, and so you actually can produce less to still meet your overall needs. I would be remiss if I didn't talk a little bit about energy storage here. Energy storage is definitely the wave of the future. So there's a lot going on with regards to building big batteries and trying to understand how we can have effective energy storage on a large scale so that we don't have waste energy and so that we can really maximize peak and off-peak times. And so one of the things that we'll talk about in this course is this sort of the bid for lithium now, and how lithium and its need for batteries is a growing challenge for everybody. So here's a little example of some stuff that's happened in Ontario with energy storage just this past year. So Convergent Energy Plus Power is a company that installed a global adjustment charge reduction energy source project, and in the PowerPoint I have links to all of these projects so that you guys can go back and take a peek. But for the Husky injection molding systems, which produces plastics, they have created this huge energy storage project so that they can limit their use of peak energy. Festival Hydro has also, they're in Stratford, Ontario, they installed a huge energy storage like battery type of a thing. Toronto Hydro is testing the world's first underwater compressed air energy storage project in Lake Ontario, which a lot of folks don't know about. And Enbridge, who does gas distribution, announced in July that they're going to undergo their first energy storage project using hydrogen. And this is actually a 2.5 megawatt storage facility in Markham, Ontario, and it's designed and built on a 5 megawatt scalable platform so that they can scale up or down and have different amounts of energy that they can store, again, to deal with peak and off-peak needs. So a lot of these things that are happening in Ontario are big projects. They're very heavy investment projects, and they're hopefully pushing us in the right direction of energy storage and energy stabilization in Ontario. So that concludes our discussion for today.